what is Vespa? Let's start there. It's a platform for real-time compute over large amounts of data, which can be used for AI. And that's what we used to call a search engine. And sometimes secretly, we still call it a search engine when the management isn't listening. So yeah, my slides are there. Skip right to it. The problem that we're going to talk about today is searching PDFs, and that's yes. This is also going to appear again at the end. Yep, the problem we're going to talk about is searching through PDFs, which is a much studied problem recently. And I hope that at least some of you haven't heard of the techniques that I'm going to present here. This is a sample of some of the PDFs that are slightly more challenging with the most popular approaches, which are basically do OCR, chunk the text, and then embed using a bi-encoder. So you have these embeddings that you can do semantic similarity over. I think you've all heard this recipe by now. I've been telling a lot of people about that too, but it's sort of end of the line for that. No one wants to hear about it anymore. They all know. And they all know that it's a pain. Right? It can be a pain, especially if your documents look anything like this. So why is this so important now? This is what we used to call enterprise search. And when we were a search engine, we did also work on enterprise search. Actually, the code of Vespa is also lived inside Microsoft as the search in SharePoint for quite some years, and a fork. So why is this suddenly so much more important now? It's because the stakes are higher. It's no longer about helping Rebecca find her travel reimbursement policy document a little bit faster. It's about building these robust AI agents that need to retrieve the information, and they don't have any other way of doing it. Or at least I don't know any AI that bugs the coworkers yet for the link, but I guess that's probably coming. So some PDFs, some documents are not nice plain text. They are slightly more like this. And this one is actually kind of nice because it is a modern document and it's actually text in the PDF. It's not just a scanned image, but it's still a bit of a pain to extract all the information here because some of it is not in a standard format. So how can you do this? Why do we extract the text in the first place? I guess I skipped ahead to this. It's about chunking and embedding and then being able to retrieve and have it be searchable. And there's a billion ways to do this and more are coming all the time. But the problem is text extraction is it is a bit messy, right? It's a lossy transformation. You can't recreate this from that text, and it's not perfect. And some information is missing, like the visual layout. It does not transfer to the text. The sections of the bar graph do not translate into the text. There's a lot of contextual cues that you just lose when you convert to text. You should still do it. It's still a good idea to do this. And I'll talk more about why, but it's not perfect. We all know that. So what's the option? Right, so this is the typical way. You embed the question, you search in the search engine or vector database, which is basically the same thing, except search engines have more features and work better. And then you give the context to an LLM as text. And there's more advanced ways to do this as well, right? You can use multiple vectors in a fancier style of embedding known as Colbert, where each token in the input text is actually retained as a separate vector, and you keep the vectors for every token in the text, and then you can do some more advanced ranking, which actually tends to work better, but it's more expensive. And we sell more compute, so that's good. So here's the other option, which is sort of what's up and coming and what I think is going to be a big direction in the future. And that is just completely skipping the part where you convert the images to text. You can just embed directly the images of the PDF, make it into an embedding, look it up in the vector database, and when you are asking the VLM to generate something or to answer a question based on the contents of the pages that you have retrieved, you just feed it the images directly, because now we have these awesome multimodal image models that can accept images as inputs, and it's surprisingly cheap, surprisingly fast, and surprisingly effective. And it keeps getting better fast. So what is a vision language model? I think most people have already tried something like GPT-4o, but I think there's been a lot of talk about using those models to extract the text. And that's a good use case. They are really good at it. But there is also a lot of other information you can extract from the images beyond just extracting the text and the tables. Like you can actually turn the image into an embedding based on the understanding of the image by the VLM. So here's the paper that got us all excited when it dropped. And I'm not an expert, right? I'm not a person that trains models like this, but I have colleagues that have worked for 15 years on enterprise search, parsing Excel documents, parsing PDFs, parsing Word documents. And when they saw this, hallelujah, they were so happy, right? Can we skip this? Can we not do this anymore? It's a pain. Basically, if you can print the document, turn it into a screenshot, and just embed it in an embedder, and that's actually turns out to be less compute to do that, to turn it into those embeddings, than it is to actually do all the OCR, the layout detection, and all the classical stuff.
Is there image recognition, like video vision image recognition will tell what it is?
Yep.
Okay.
I was just saying that how does it recognize the image, or how does it tell what it is? Is there some kind of image recognition or training around that? Or does that depend on the LLM?
It basically uses some of the layers of the visual model and uses the image as input and generates an embedding the same way that it's done for text. But it's not my field. I'm not going to try and explain that part. I just know that this model exists, it works, and it's useful. And I also know that since I made this presentation, new and better models keep appearing, and I love it. So this is the model called Poly, which stands for Contextualized Late Interaction over Polygemma. And Polygemma is like the base visual model that was used to create this embedding model. And ColPoly is basically based on the name Colbert, which is a previous paper that did this, a similar thing for text, where you generate multiple embeddings for the text, not just a single embedding, right? You keep the embedding per token, and then you can do ranking over that with something called MaxSim. It's called late interaction because you do the interaction later. What you do is by creating multiple embeddings for the query and multiple embeddings for the document, you retain more information to be used at a later time. When you know what the actual query and the document pair is that you're going to evaluate, you have more information at that time and you can make a better judgment whether that document is relevant. So you can get a better relevance score, a more fine-grained thing, if you will, than if you only have a single vector space point for both the query and the embedding. So basically that allows you to apply more compute at that time. So we can see how it compares to the more traditional methods. And of course, people make benchmarks, and whenever someone makes a new model, they have this awesome benchmark where their new model is the best in every case. In this case, it turns out that it does really score really well, and that is with a small model and not a lot of training data. And we saw this as a very good sign that this is something that is going to keep getting better in the future. And we've seen a few cases that happen already. So you can see like the increase in the score here from 0.66 to 0.813. That's pretty massive. So some of the benefits of using this polymill is you don't have to think about mapping the complex format to the domain of text. You just embed. Yeah, I guess that sort of repeats. You don't have to do OCR. You use the built-in capability of the visual model to recognize the text. And it's actually really good at recognizing also different fonts, handwritten text, all kinds of text. And when you do OCR, it's lossy, right? So if you get something wrong in the OCR, when you turn it into text, it's really hard for a later step to recover from that error and be able to understand, oh, it probably meant that, because you've lost a lot of the visual information. If you keep the visual information, then you can see actually this also looks a lot like that word, and it's easier to be able to recover from that. So engineering simplicity, there's a lot less code involved. You can run it on a GPU, which is more compute efficient. And gives better relevance, at least in some cases. So we can dive a little bit deeper into how this works. So what you do is actually you divide the image into 32 by 32 called patches. And this is standard for visual models. And what you do is you don't end up combining all these patches into a single embedding, but you do retain the individual embedding for each patch. So for one image, you end up producing 1,024 embeddings. Luckily, they're not huge embeddings. They're 128 dimensions. And you don't need them to be as huge because you're not representing the whole image. You're just representing a small patch of it. Another important thing here is that each patch is not recognized individually, right? Because that wouldn't make sense. A lot of these patches only cover a small portion of the text, and that wouldn't really be enough for you to understand what this is about and determine if the document is relevant. So the embeddings are contextualized and generated based on not only that patch, but all the other patches in the image and how they relate to each other. So I'm gonna give a quick demo I'm gonna try and give a quick demo what this looks like when we've done it. So here's a quick application we built to sort of show off how it can be done with some sample queries. Let's try this. So the idea is it should be pretty fast. Yeah, the internet here isn't great. It's faster at home, I promise. It's downloading a lot of images. We can see that it really quickly finds the query results and the relevant scores for each result. And then these top 3 images. And here we have both the image, which is retrieved by the model, and also the extracted text. But in this case, we don't actually use the extracted text. We just take the top 3 images as considered relevant by the highest embedding score and feed them directly into the Gemini 2.0 model as an image. And then we ask it to provide an answer for our question. And in this case, it does. It's able to read from this very poorly formatted bar chart and correctly identify the right numbers. And this is something that, yeah, it's actually is represented here as text, but it still would be very hard for a text extraction model to successfully extract this, because you have to look at the color blue representing new hires and then identify the numbers for the different years based on those bars in the chart. Another thing that this model is able to give us, because it's based on multiple embeddings, which I personally think is very cool, and I've spent a lot of time exploring the different query results like this, is some degree of explainability, which is often a problem in AI search. Why is this document the best? It has a score of 67.2. What does that tell you? It tells you absolutely nothing. And it's really hard to get any sort of explanation about why a semantic search result is the way it is. But in this case, we can see that when I'm searching for child jumping over puddle, we are actually separately computing the interaction between the tokens in the query and the tokens in the image. And we can see which of these 1024 parts of the image had the best similarity with the tokens in the query. So if I click the word child, you can actually see sort of a heat map of where the model identifies a child in the image. This is very cool, and I spent a lot of time trying different queries. And we can see if I click jumping, and now you can see there's more focus on the arms and the legs, which I guess are the parts that are typically associated with the motion of a jump. You're going to move your arms and legs. And similarly, if I click puddle, it's going to pretty well identify the puddle. And there's no text you can extract in this picture that would be able to tell you any of this. You might be able to ask a model to describe the image and get a hit from that, but you wouldn't get this nice heat map. Great. So here's the data set we used for this. This is actually based on a Norwegian set of documents made by our global pension fund, largest in the world. And their yearly reports from the different years for this. So it's a set of PDFs that is, I think, around 7,000 pages. So it's not large, but large enough that you wouldn't really be able to just give all of this to any of the current visual models and be able to ask it questions. It wouldn't be able to retrieve relevant information over that large a context. And we have done experiments with larger data sets where we are able to show that we can actually scale this to be efficient over a very large corpus of documents. I think my coworker mentioned billions in one of our blog posts, and that's quite real. Why did we build it? Because we built a demo that had a nice JSON output and no one was impressed. Surprise. So we wanted to see if we could really build something like a UX on top of this that had a snappy search response and have a good user experience, And we haven't really worked super hard on making it great in a lot of different other ways like that. We haven't been fine-tuning the model. We haven't been optimizing the prompts too much. Mostly we just wanted to see if it could work and if we could make it scale and make it snappy and fast. And I think we succeeded in doing that part. Yeah, we went through most of this already. It's my backup slides. So why did we build it in Python? This was written by my coworker, Thomas. He loves Python. I learned to love Copilot. Thank you, GitHub, because I had to learn Python doing it. But it was actually pretty simple. And as none of us are designers or JavaScript developers, we actually found that using this fast HTML framework to build it in Python was really fast and efficient for us. Allowed us to write code in a way that we were more familiar with and just insert the little pieces of JavaScript where we really needed them. So that was nice. And also we did need PyTorch and transformers and everything to do the inference of turning the query into the 1024 embeddings. So we had to do Python anyway. Yeah. As I said, we wanted it to be snappy and nice. And no designer worked on this project, which might be obvious to some. But personally, I think we made it look pretty good. So here's the sort of architecture of the system that we built. And all the Python stuff is in the middle. Doing the query embedding when you get the query from the user on a GPU running on Hugging Face. Sending the query embeddings to Vespa, which acts in this case as a vector database, and then getting the response back. And one of the keys to making this fast is that we didn't actually have to retrieve all the vectors out of Vespa and then do the calculations inside our Python framework. We were able to write the expression that computes the similarity score over all the embeddings for the whole document to run inside Vespa. And then it actually returns out both the relevant score and also the result from those computations, which is the heat map, basically, the relevance of each patch compared to each query token. And if we had to actually go and retrieve the images and then sort of re-infer over the images, yeah.
How do you count the tokens? Because you are using images, right? And I know Gemini 2.0 Flash, now it's 1 million tokens that allowed you, like the context window.
Yeah.
But with images, how do you count those?
I don't personally know. I know that we can give it 3 images and it's really fast. And that doesn't seem to be too expensive at all. There is a calculation in the pricing page on Google, and I wasn't too concerned with looking at it because it's not that many tokens. It's surprisingly cheap to do that.
Inference.
Yep.
You mentioned the previous slide also here. Can you explain where that happens? Is that when it's chunking and embedding? Is that where the inference is happening? Is there inference?
Yes, that's right. There's inference happening when the documents are sort of embedded and inputted into the Vespa system. And that's not part of this slide. But then there's also inference happening at query time, where you take the user query, which is a small text string, and you turn that into a number of embeddings inside the same embedding space and use that as the query.
And so what are some of the factors that make for better the inference engine works better? Like, what do you have to kind of do in those stages? I mean, you don't have to go too deep, but just, is that a parameter that is important to make that, because increasing the success rate of the inference engine is a key part of it being successful?
So key part of being able to do this at all is to do the inference. You need it to be fast, right? You need to be able to turn the user query into text reasonably fast, and you don't want it to be a huge amount of data. So one important part of this for us was that when we do the inference, we quantize the embeddings and we turn those 128 vectors into 128 bits, really reducing the dimensionality of the query and the number of bits that we need to transfer between the Python frontend and the Vespa backend. But of course, there's always a trade-off in a model like this. How many dimensions should you have? How high resolution should those dimensions have? In this case, we found that because there's such a large amount of embeddings for the image and the query, that we can compress it down a lot to binary quantization.
Hi, how did you go about the training phase or pre-training phase?
We didn't train this model. We got it from Hugging Face.
I see.
Yep. So that was done by the authors of the Kolpali paper. And since then, a few other models like this have appeared based on more modern visual models like Qwen 2, which I think is the current best one. So more benchmarks and papers do keep appearing in this domain of doing RAG completely visually and doing sort of multimodal query answering over complex documents like this. This is one released January 15th, so almost a month ago. And this also has, as they tend to, training set that you can download and a benchmark competition that you can participate in if you want to train models, which I don't. But it's cool for those who do. And a lot of new models, visual models keep appearing, right? And the improvement in visual models is quite drastic over the last year. Like the step from the previous model that we used for this, which is Gemini 1.5, to Gemini 2.0, which we're using now, was really great. We found that even after retrieving the correct pages that had the information you were looking for, then the later and larger visual models are a lot better at finding and extracting the information from those images and finding the correct entries from a table and being able to interpret graphs and other visual elements. And of course, the traditional parsing methods for turning documents into text, they keep improving as well. And this is also really important and really good. And if you can search text, it's often cheaper. If you have text, you can also use classical search engine techniques like lexical search, which can be a huge add-on to the quality of your search, especially if you're looking for something that is exact. If you're looking for someone's phone number, if you're looking for someone's name, and other exact information that you can find in the text, then the classical models are still really good for helping you improve the quality of your search and the quality of your output. So obviously this is still important, and also the size of the context window is a lot bigger for just plain text than it is for feeding the model lots of images, because they do contain a lot of redundant information and white space and other things that don't really help answer the question. So is vision all you need? I think I answered this already, no. But I think it can be more and more of what you need. And if you have these difficult documents, then I think this is a very promising path to walk down. It depends, of course. And yeah, any questions?
Did you find a way to convert a bar chart to a table?
No.
Okay.
We just gave it the image, keeping it as simple as possible. You know, I find that bar chart hard to read, and Gemini 1.5 couldn't do it, not reliably. And Gemini 2.0, it can. Yeah, it finds the right numbers every time for our cherry-picked sample queries, which tend to work well.
So based on your chart that you were showing,
Yep.
ChatGPT 4.0 is still the best in terms of visual, because that was the highest.
I think at the time this presentation was made, then yes. I don't think there are any of the new reasoning models yet that also have visual capability. I think that's probably coming very soon. And at that time, I expect.
What would your existing model do with an image? How would they treat it?
I think they would treat it the same as they would treat a textual context. And they would still interpret the image in the same way that they already do. But then they would reason over that using multiple text tokens, like we can see that DeepSeek and the other reasoning models do today. And I think that might be a very valuable way to be sure that you're getting the right answers. So I think that's going to be able to hit the models even further in understanding the visual, but we'll see. That's I'm not a model trainer, but I think we'll know soon.
How do you calculate relevance score?
That's the fun part. I'll skip ahead. Ooh, I think it's in my hidden side. So that's the max sim operator, which is how these call-poly and also the call-BERT model, which uses max sim for text tokens, does it, is that you find the maximally similar, for each query token, you find the either the image patch that is maximally similar to it, or the text token that is maximally similar to it. And you do that for each query token, and then they just sum up those similarity scores. So you basically see how similar are each of the parts to each part of the query. And you take the most similar pairs and just sum the scores from those to retrieve, to get your final relevant score. And that is something that we are able to do internally in Vespa. So you don't actually have to go and retrieve the documents and then compute it in Python, but all the vectors are stored inside Vespa. And then you can actually just write an expression which is executed where those vectors are already stored in memory, which means it becomes reasonably fast. You can do it. If you have to actually transfer all the data to the front end and compute it there, it's going to be a lot more expensive. And yeah, so for my ad, that's sort of the use case for Vespa, is that you can push a lot of the computation that you need to do over tensors and embeddings and vectors and other inputs. You can push those computations down to the nodes where the information is already stored in memory, instead of having to go and retrieve that up and do the computation in a sort of inference layer. So this application is all open source. You can download the Python and see how the rank scoring is expressed in Vespa and how the front end works and everything. There is a link in here somewhere. Yes.
So I think classical OCR is pretty sensitive to noise in the images. And I'm wondering if these image-based techniques are more robust in the case of noise or compression artifacts.
I think they are, but I think you can also get that by just asking a visual model to extract the text of the image for you. But then you do have a lossy transformation, right? So if the visual model gets it wrong, then it's really hard to recover from that later. But in the context of a query, if you provide both the query and the document to the visual model, then it sort of knows what to look for. It's not extracting all the text, and it's able to sort of focus more on only the interesting parts. And I think you can get higher quality that way than extracting the text using a VLM first and then inferring over that.
Still have like 10 minutes.
Oh. If we don't have any more questions, I can dig into the code.
Question regarding HTML content. Can you talk about the performance of rendering an HTML, mainly for dynamic pages? So suppose if you have a page that gets rendered via a JavaScript, so if you curl the page, you get a different response rather than you actually render the page. So how do you have you had any experience with that? How does that play out generally
Yeah,
speaking?
the performance difference of sort of the front end aspect of this. I think it's, of course, there's a trade-off between transfer size of the generated HTML. So if you're generating a huge HTML response containing a lot of tags and so on the server side, and then you have to transfer that, and that can be damper on the performance. In this case, that is completely overshadowed by the fact that we are transferring a massive amount of images containing these similarity maps. So in our case, we really couldn't see a difference. And I think for us backend developers building a demo, that wasn't really a focus. It's just it worked more than well enough for us, especially considering the fact that we're also transferring a lot of large images like this. Yep, I think that's it. Thank you.
Okay, next up, Alex from Alumnium. I like your computer.
Yeah, that's good. Choose me wireless. Okay. All right. Thank you so much. Thank you so much for having me here today. My name is Alex. I would like to talk a little bit about the open source project I've been working on for the last few months. It's called Alumnium, and it's pretty much the open source tool for software testing of web applications. So I work as a quality architect, and I'm not a ML or AI engineer. I've been doing software testing my whole professional career. I'm also doing a lot of open source work. Some of the things that I think I'm proud of would be I have created a fairly popular application for Mac that's called Mac-A. It has 10 like 1 million downloads, and probably somebody here might be actually using it. I'm also doing participating in big open source projects like Selenium. I suppose people you guys might have heard of this project. It's a browser automation tool, and it's actually a standard in W3C. I maintain everything related to Ruby in this project, and I'm also a Ruby maintainer within the Bazel ecosystem. I created and maintained the main parts for Ruby language support. So as I mentioned, I'm a software tester, and I've been doing software testing my whole career. And throughout like 15 years, I've tried to figure out what is the biggest pain of doing testing, writing the tests for web applications. And for me personally, It was less about writing tests. It's definitely tedious, and I think it's way easier nowadays when you have Copilot or maybe Cursor, when it can kind of generate the scaffold, the tests, the interactions. So once you figure it out once, it's more streamlined. You just know how to write the code, you structure it. However, supporting these tests once they're created is a huge pain. Because if you have hundreds of tests and you develop a big project, whenever the UI changes, some slight front-end changes are happening, the tests start to fail. You have to deal with different kind of flakiness when tests fail at random place sometimes. And then whenever some big, massive change is happening, maybe like replacing the front end, I don't know, from Rails to React, that breaks everything and you have to deal with that. So I was trying to figure out with the rise of AI if there are some tools that can actually help with that. So I mentioned Copilot. It's great. It allows you to write tests faster and iterate easier, and you can chat and figure things out. But it doesn't really help with these problems of supporting tests. The tests would still fail on CI from time to time. I think anyone who has done web development at a certain scale and have had some kind of tests, Selenium, Playwright, Cypress, whatever, they would deal with flakiness. And Copilot, unfortunately, is not super helpful for that. So I started trying to find, is there any open source solutions that are specifically targeting testing? And basically, I've have found two buckets. There are AI-powered test generators, and I'm going to talk a little bit about the project called Lavag, which is pretty cool. I'm going to show it to you. And then there are tools that are roughly the AI-powered test runners, where you would run a test and then they would use AI during the execution of the test to make it stable, robust, and without little interaction. And I'm going to show you a project called Short Test, and eventually introduce Alumnium, which is the project I've had to start. And for the purpose of this presentation, we'll be just doing some random thing to test. We have this web calculator, which is very simple, and we want to write a test that 2 + 2 = 4 on this web application. So how would that work with different tools? Lavag is a very interesting project. Check it out if you haven't never heard of it. They're trying to build a web agent, an open source web agent, but they also have a very specific tool for quality assurance. And the way it works is that you would create some tests in Cucumber format, and then you would use a CLI tool that will read this test, send it to GPT-4o, and kind of iterate over the test, looking at what you have in the browser and trying to create the Selenium code that will satisfy this test. So once generated, you have the Python scripts. You can commit them to your repository. You can run it on CI. And then whenever maybe UI has changed or the tests start to fail, you can just regenerate them and see what they do. So you would have this test, for example, calculator, 3 steps, load the homepage of this app, do 2 + 2 =, and then verify that the calculator shows 4. You would run this CLI tool, give it a URL to the web app, and then it would start the browser, do some work there, and then essentially finish saying that it finished in 52 seconds and generated some tests. So we can actually go ahead and inspect these tests, and it would create a bunch of code that is generated by GPT-4o. For each step, it would create some interactions with Selenium, like clicking some elements, but finding them by XPath and clicking them. And then for the next step of assertion, it would also do the same thing. It would try to find some text field on the page and then assert that its value = 4. And then you can just run this test like any other. And it's pretty fast because there is no AI involved. It just finishes in 1 second. Great project. I really like that you can actually see what's generated. And once the tests are created like that, they're super fast and they're very cheap because you only pay for the generation phase. The rest is just regular execution. But unfortunately, I couldn't use it in my real work projects because I have a lot of tests. They have certain infrastructure, certain test runners. So I can't, for example, use Cucumber, and I can't really integrate these tests because the way Levag does it is just it creates code for everything. And I was a bit bothered by the fact that these are still tests that would fail every once in a while. So you have to regenerate that every time. I can kind of cumbersome. That's not what I really want to do. So the next project is called Short Test. I think it was fairly popular. It has like this big, very popular at some point. And it's a different type. It's a test runner. So you would write some tests in a TypeScript in the short test format that it expects, and then you would just commit them to repo, and then you can run them. And the way it works is that during the execution, it would use computer use API from Anthropic to actually interact with the browser. So if you're not familiar with computer use, the way it works is that basically we're taking a screenshot of the browser, we're sending it to Anthropic and say, how do we do something? And then Anthropic would say, move the cursor 10 pixels left, 5 pixels down, and then press left mouse button or something. And basically you do that in a cycle. And that's how this test works. And it's very short. So it's short test. It looks just a single line. You can define the whole test in a single line. And then when you run it, it would actually start the browser, start taking screenshots, send into Anthropic. It's a bit slower, on the slower side. So you can see it did finish successfully. And it took about a minute on that. So it's very easy to use. That's amazing. I think computer use is really cool because everything happens in runtime. So if your UI has changed, you don't really have to change anything. Computer use will adapt to that. But again, it's a separate test runner, separate expectations in terms of infrastructure. So unless if you're working on a new project, that's great, you can start using it. But unfortunately for existing projects, it's very hard to integrate. And on top of that, it's very expensive and very slow. Computer use API has this challenges. So at this point, I kind of ran out of any open source projects. So I started working on something for myself that I could use in my work. And that's how Alumnium project was created. And the way I was trying to design it by creating just a simple Python library, something that wraps the browser automation tool Selenium or Playwright and exposes very simple API on top of it. Like you can do something on the page, you can get some information from the page that you can then verify or assert, or you can give a free-form instruction to check that something is true or not, depending on the page contents. And because it's just a Python library, it doesn't have any requirements for testing runner, you can use it with whatever you want. So it's very easy to integrate, and it started to provide me this gradual migration path. So I could, if I have 100 tests and I have like thousands of lines of code that support these tests, I can start removing some code because I no longer need these browser interactions. I can replace them with few lines, and the rest of the testing still works. They use the same Selenium code, they use the same infrastructure, nothing really changes. It's just that I can start cutting things out. And as I was working on this project, I was first of all trying to make sure that all major AI providers were supported, like Anthropic, Google, and OpenAI. And it had to be that cheap. It has to be super cheap, because if I would come and say, hey, at work and say, hey, let's use this new AI-powered tool that costs us a few $1,000s per month, nobody would really let me in. Do that. So I was trying to build it with these low-tier models like GPT-4o Mini, Gemini Flash, or Claude Haiku. Eventually, when things started to work fine, I also added support for open models. So the project works on Llama 3.2. And yeah, it was from the very beginning an open source project under MIT. So anyone can do whatever they want with it. So the same kind of test would look with Alumnium would look something like this, where navigate is just a helper function to go to open the URL in the browser, but then we would tell Alumnium to do something on the page, and then we would say, hey, give me the calculator value after you're done, and then we just run assertions as regular Python code. We can run it as regular test. This is PyTest because I use PyTest, but I also, it works with unit tests or Cucumber or whatever other framework you might be interested in. And it runs in just 8 seconds, so it's fairly fast. I think we have some time for a quick demo. So let me give you another example. I want to show you the simple test that I've just written today as I was going to the meetup, which is a test for a simple internet shop, where we would go to this application. It's called Sales Demo. It's an internet shop. We would log in, and then we would add some items from the products page, go to shopping cart, proceed to checkout, finish the checkout with some information that we want, and then assert the information, the amounts from it. So like it would take the item total without tax, it would take the tax from the page, and then take the total, which is supposed to be like the sum of these two. After that, it would finish the checkout and then do some extra verifications, like check that there is this massive big green check mark, and it will do it by taking screenshots and talking to a visual model. And then there is some extra thank you for order message. So let me try to run this. So this is the website. You can see that it's typing some standard user secret sauce. Now it's going to add some items. We have backpack and onesie. Now it went to a shopping cart and just clicked through it real fast. Now it's tried to fill the information that we had in the test, like first name, last name, and zip code. Proceed to the next phase. This is our data about the pricing without tax, with tax. So it retrieved it, run the assertions, and now finished the checkout. And at this point, we're done. The test is passing in about 40 seconds. Okay, so in terms of performance, when I was working and trying to figure out how this compares to other projects, some numbers for Lavag, which is the test generator, it takes about 50 seconds to generate such a test for this calculator that I've shown to you. And then after that, it's very fast, like just 1 second. It's a regular Selenium test. Short test would be the slowest one because computer use is very slow. So the same test takes about a minute. And for Alumnium, it was like 8 seconds during the execution. As I mentioned, the cost is something that I was very, very concerned as I was working on the project. So it really all boils down to what kind of models are we using. Lavag is using GPT-4o. So to generate a single test, you would pay something like 8 cents, but you pay it once, and then you run it until you regenerate. So that's pretty cheap in my mind. Short test and computer vision, from my point of view, is just unreasonably expensive. 15 cents to run one test, and I have hundreds of tests, so it's going to be thousands of dollars per month because we have hundreds of tests, and then we run them on CI on every push to master. So that's just not realistic. And as I was trying to measure the costs for Alumnium for this particular test, it was actually less than 1 cent, and OpenAI was not shown to me. And I had to export, so it was around basically 1/10 of 1 cent for a single test. So depending on how you compare it to other, it's like hundreds times cheaper. And of course, the mileage varies, right? So depending on how complex the test is going to be different, but still in this project, which I started a few months ago in January, it has CI, we run thousands of tests. And the bill from OpenAI was like $4 per month. So I think that's totally worth it. I wanted to mention a few challenges that I had as I was building. So my expectation, I'm not an AI engineer, my expectation was that LLM would just take a lot of complexity and I will not have to write this Selenium code. It will make it faster and more stable. In practice, it introduced another layer of just randomness, and now you get another source of flackiness. So trying to make sure that the responses from models would be as predictable and as repeatable as possible was definitely a challenge. And it's not 100% solved, but it's pretty good for now. Taking that and scaling that to support all these different models, Gemini, Claude, it's challenging itself because things that work very fine for AI, OpenAI doesn't really work for Anthropic. What kind of prompt? How do you structure that? It's all different very much. And at this point, I would say that it's pretty good and it's working on smaller sites, but it's not really scaling yet to large applications like Amazon or maybe YouTube. As I'm trying to test it, I will constantly either run into context limitations or other kind of just non-reasonable behavior of the application. So this is the challenge that I still have to solve, making sure that the performance is also great along the way. And the way it works internally is it builds an accessibility tree of the website. And for websites that doesn't really respect accessibility, it just doesn't work. So this is another challenge I'm yet to solve. It's a Python library, but eventually, like Selenium, I would love to have other programming languages and mobile application testing. It works on open models, but it's not working yet with local models. That's something I had for version 1.0. And I think at this point, it's kind of obvious that I have some tests. I know it's working, but I need to kind of scale it and do some evaluation. So this is something I'm interested in creating. Thank you very much. There is a QR code to the website. Check out the GitHub repository. We also have a Slack channel in Selenium Slack, or where you can ask any questions. Give it a shot. It's an open source project, so maybe it might be useful in your testing. And let me know. Feel free to shoot me an email if you have anything to ask. I'll be happy to chat. Thank you so much.
Thank you. I didn't fully understand to what extent do you send screenshots and to what extent do you use the accessibility tree? So imagine there's a web shop that has, let's say, lazy loading. So visually there's nothing yet on the page, but the accessibility tree might already have some of the information that will be available after scrolling down. Can you just explain what exactly are the limitations of the accessibility tree and what is a screenshot?
Right. So screenshot is just a screenshot, what we see in the browser, but accessibility tree is what the browser gives. They're complementary. So by default, screenshots are not used at all. So it's just the accessibility tree that is being used. And then it doesn't work for when you want to write a test for something visual, like let's say you want to verify that font style is strike through. This is not exposed through accessibility tree. For these things, what I would do is I would just have this extra vision that would take a screenshot and then send it, and that's usually enough. Yeah, you can flip that vision. Again, from cost perspective, sending screenshots every time is not worth it. Most of the things are in accessibility tree already, but for certain things you have to opt in. That's kind of.
You need to know what is accessibility tree exposed and what is screenshot.
The way it usually works is if I would run it without screenshot, like if I would remove this, it would fail with a certain error saying that there is no information about what is the green check mark. And then you kind of, okay, it's not there, and then you add vision, and then it starts working.
Just run everything visual.
So if I run everything visual, A, it's gonna be more expensive. B, accessibility tree goes beyond viewport. So you have a large website, you can actually kind of reason about elements that are not visible yet. And with screenshot, you have to scroll through the whole page, take screenshots, maybe join them, or maybe send them in chunks. But in any event, that's from my so far experience, that's just not worth it, because the accessibility tree is better. It's more compact. The less is more. So the less I send to LLM, the more predictable it is behaving. Yeah. Thank you.
I got one. This might be more of a suggestion. I think you have a lot of the elements in place already. When you do sort of your graph based on your website and you're extracting that information, you're setting yourself up really nicely for a page object model, right? And when you have that kind of structured data, you can kind of leverage keyword-driven frameworks, and that can be the basis for both your evals and to add to the determinism for if you have a structured keyword-driven sort of check that you can do. Then you have a lot more leverage to be able to do not only human-in-the-loop testing, but also automated testing, because you're not dealing with things that move around. You're dealing with something that you checked once and then it kind of expands for that website over time.
Okay. Yeah, thanks. Let's talk after.
Sure.
I would love to learn more about that.
Is there a setting for checking against how much fuzziness is tolerated? Like, thank you for the order, if you want that to be an exact match, versus if you want it to fail if it said, thanks for the purchase?
There is no such setting. This is something I'm kind of on the fence for. From my point of view as a test engineer, if something is not 100% accurate, the test should fail. It should tell you immediately, so you don't really control that.
Right, that's more of a product decision than
So the way I'm trying to build it is that it should fail, and then you kind of iterate on making sure your statements are.
How does the AI know what the product decision was? Is, I guess, my basic question.
Yeah. And I'm still having troubles with that, because, for example, if you make some instruction and you make a typo, usually LLM just understands what you mean and kind of compensate for that, which is fine, but maybe not always. And maybe you want to make it very strict, right? And you don't want to tolerate any kind of misspelling. So yeah, I think at some point I'll have to add it.
I'm not sure if this is related or not, but regarding screenshots, does the new Microsoft OS is going to be taking continuous screenshots, right, of everything you do to train their AI, the personal assistant and stuff. Does that, would you be able to use that aspect of the OS now that's doing all the screenshots, or is that a totally different thing?
I think that would be more like a computer use API for Anthropic, and I think it's very complicated to implement. Because I think the way it might work is you take a screenshot and then you say, I want to do something, and then the model should tell you where the coordinates where you have to move the cursor and click. And so far whenever I try to implement this with existing providers, whenever they had to spatially reason about the screenshot, they always mess up. So I can't make it work reliably if at some point it works. And I think what Anthropic did for computer use, they actually trained a separate version of Claude 3.5 Sonnet on top of that for this particular use. So I would love to, but that's definitely beyond my reach.
Hi, clean demo. So I have a basic question. This is the first time I'm seeing something like this, and there is not a lot of jargon where you need to write a lot of code or something like that. trying to understand, like, if you know the text, like the navigation pages and stuff like that, you can probably write this for any website, correct?
Yeah.
And what would it do behind the scenes? Like you said, al.do.
Yeah.
So what's it doing behind the scenes? Is it writing some Selenium code or something like that?
No, I can show, it's actually quite simple. Might not look very simple, but the way it works is we tell it to do something, and then first there is something like a class that would fetch the accessibility tree from the browser. And the accessibility tree, it's not a DOM, so it doesn't have a bunch of noise like classes or IDs. And it's very simple, like there's a button, this is the name of the button, it is enabled, it is visible, period. So it's very simple. And then based on this accessibility tree, we would give it to LLM and say, how do I actually do 2 + 2? And it will give a list of steps. And then for each step, we would feed it again into another communication layer with LLM that has a bunch of tools like clicking, typing, pressing keyboard keys. And then we take, like, how do I do this particular step? And then it will give us functions. We will send them back to the browser. And because accessibility tree is used, it's very tolerable to UI change. So like if I have a task for Google to search for something, and then when I try to replace this, let's use DuckDuckGo, it's similar enough. The accessibility tree would have a search box where you type something, you press enter, and then there is some list of search results. So theoretically, that can be written for any internet shop.
Great. I would love to try this, because generating tests, oftentimes in enterprise, it's dependent on someone who is technical, like a QA automation engineer. And there is a dependency, like, can you do something for the client side? You may not get that kind of a resource power. Probably this is something people can try out, and for client specific testing, I'm saying.
Please, the best thing you could do is try it out and raise bugs if you see something.
Thank you.
So one more question. It sounds like you use this in production in your own company, and you made the models pluggable. In production, which model do you use, if you can disclose that?
GPT-4o and the mileage. So from stability perspective, they're kind of the same. From a performance perspective, they are much faster. So at least in my experience, GPT-4o was faster than Claude, and I haven't really benchmarked Gemini 2.0, but actually, if you're not particularly concerned about performance, because it works in Gemini and Google has a free plan with kind of lower requests per minute, we can actually write all this for free and have your tests running on CI for free. And it's fairly stable, just slower.
Thanks.
Yeah, I was just wondering, since you used the accessibility tree, if you had tried just taking the rendered HTML, like inner HTML of the page, and sending all that, how that worked.
So as I worked on Selenium project for years, one thing I learned is that DOM just has too much noise. First of all, there is no way to understand what is visible or not. So if you have a button, you actually have to use some JavaScript API to try and understand if it's visible. And there is not a single 100% way to do this through JavaScript API. And the accessibility tree is more reliable. It has its own challenges because every browser has its own implementation. This thing works in Chrome, so I haven't yet even added anything else. But the way it works is that browser kind of tries to make sure that what it gives to operating system is actually what is visible. So it would remove from the tree automatically things that are not visible. And it looks way more compact. And if I just give HTML, there is also some random elements and some random tokens that kind of start confusing model.
The model is more likely to get confused. Okay, cool. Did you ever try just both, like giving it everything and see?
Try what?
Try giving it like the accessibility tree and the HTML and see if it
and
just...
HTML?
Yeah.
No, I haven't tried to do this both. Not sure how they work, but I was looking at how different projects use. So there's like this great projects like Browser Use, Stagehand. They're not focused on testing, but they're trying to build web agents, and they have their own kind of the way they implement it. So I think Browser Use would take a screenshot, try to with JavaScript build a tree, and then actually draw boundaries around elements, and then use this with screenshot and tree sent to LLM. And it's very, if anyone ever used Browser Use, it's really great. It's very, very awesome. And there is another project, Stagehand, which does something similar, but they all have their own implementations. So yeah, I feel like at this point, nobody even tries to do the whole HTML, especially because you just run out of context like immediately.
Mm-hmm. Okay, thanks.
Thanks.
Did you want to ask him?
Yeah. Did you ever get surprised that something it did not catch?
It did not catch?
Yeah.
Yeah, especially in the beginning, like one of my favorite example, I have so many screenshots where I like, why are you doing this? Okay, so this is one of my favorite examples. The question is, are there 3 paths on the page? And it says yes, or it says no, but it also says yes. So it is passing and it's failing at the same time. So I was, okay, how do I compensate for that? I would then take this and take the original statement and then say, hey, do they actually contradict? And usually that would be like a compensation mechanism for this. Another example I love is, where is it? Maybe here. Yeah, so you have 2 squares and then you're going to give it a screenshot and then you're going to say, is square B to the left of square A? Or square A is to the right of square B? And kind of the same thing, right, for me. But they say, no, that can't be true at the same time. They're like contradict to each other. And at this point, I've stopped trying to make LLM specially reason about this. So yeah, I have a bunch of screenshots like that where things confused me, but at this page, it's actually more stable. And the nice thing about using this is sometimes it tries to predict what to do next, based it on a common user experience, and not just based it on the accessibility tree. For example, if you have a to-do application and you want to remove a listing to-do item, you have to hover it. There will be a cross sign, and then you click on it. But when you ask LM, how do I remove this to-do item, it doesn't know because there is no button yet. But it kind of thinks, okay, maybe I should try to hover it, and then you repeat it, and that's actually was pretty nice. But yeah, in the very beginning, I was having a lot of false positive or false negative results. Now it's way more stable.
Thank you for putting this together and for the presentation. This looks really cool. The testing pyramid tells us that we should minimize end-to-end tests because they're very brittle. And I'm curious, in your experience so far with this type of tool, do you find it to be less brittle? And do you find it to sort of encourage you towards writing more end-to-end tests?
So far, I don't have that much experience to share. To kind of give you, projects I work are very respective to the test pyramid. So if we have, let's say 500 tests with Selenium, we would have like dozens of thousands of unit tests. And so far, what I'm just trying to do at this point really is make sure I can start removing and let's say replace 10 tests we have with this, which requires 10 lines of code versus hundreds lines of code in page objects, classes, and everything. But it's a bit too early for me to kind of show if it's more brittle. It's definitely, in my case, not encouraging to write more tests. It becomes slower, but I'm fine to pay that because there is less code to maintain and support, and there is less flakiness so far.
Thank you.
Thank you.
So maybe one last question.
Questions.
Some of these challenges that you're addressing, the contradictions and things like that, and then it's getting befuddled. Would an agentic approach overcome some of these? Like, are there some elements in kind of agentic AI approach as opposed to the standard LLM approach that would help them figure that out?
So I'm a bit on the fence with that. On one hand, as I was experimenting with agentic loops, it was allowing me to push forward. And yeah, it was solving this. But on the other hand, it would start introducing false positives because it would try to assert something and the assertion would fail and then say, okay, maybe I need to try something else. And it would try to do something else through some other path on the website. For example, if you look at this example with Internet Shop, I probably can't open it, but there is a list of the products and you can add them on the products page, or you can open the product and then click add to cart on this page. So if one of these is broken, what the agentic loop should do, it would try to open the product and then try to again add it. And that's fine. The test would be passing, but I actually want to know that it tried to add the product on the first place and it actually failed. I want to test to catch that. So I see how it can be beneficial, but I also see how it can create false positive results for testing. So I'm not 100% sure if that's the way to go. And all the agentic loops and tools like short test suffer from that because you might tell it to do something that is impossible to be done, and it would try actually to do something that resembles it, and it would pass. So I really try to avoid that situation where you would have green CI and things are actually not working, because that diminishes the value of the tests. Thank you so much.
If you have any other questions to Alex, please go talk to him later. Okay, I think we have 15 minutes for community shout out, but is there anyone hiring right now, or is there anyone who is looking for opportunities? Oh, okay.
Thanks. My name is Dick Polipnik. I'm working on a healthcare AI startup right now. We've got a couple of customers using an MVP that we've deployed in their clinics. We have around $100,000 in annual contracted revenue recurring. I am not the technical founder, and I am searching for a founding engineer to help me get this product from an MVP to a beta and get it to market and get something that's scalable that we can start to get to market, essentially. So we've got our customers that are banging down our doors and asking to make introductions to other people in their networks, and I'm having to turn them all down because our model isn't scalable, because I need a founding engineer to help me build something that is. So if you're interested in healthcare and AI, you've got the chops, and you are interested in building something awesome, I would love to come talk to you, or come talk to me after this. Thanks.
Thank you. Okay. Is there anyone hiring? Okay.
Hi, my name is Fal Sarkar. I work in partnerships and business development. I build ecosystems, from scratch. So if anybody's interested in building a partner ecosystem, building relationships, and then scaling an ecosystem, I can help you with that.
Hello, my name is Johan. I'm a recent Boise State graduate that just moved to San Francisco 2 days ago. I'm currently working on a music AI application. So if anyone's interested to know more about that, just let me know. Thank you.
Hey, then is there anyone who wants to do a quick demo of the projects that you're building right now? We have like 5 minutes per person. Anyone not building fun projects? Oh, okay then. Yeah, please come up.
So who here is a parent? Is a parent. Dog parent, I don't know. How much email do you get for dog parenting? Let me put this on. Okay, well, while I get this up, let me just introduce myself. So my name is John Shea. I've worked in data for a long time. I worked at Cloudera for 12 years doing open source database stuff, but more recently I've been focusing on LLMs and building things that are actually useful for people as opposed to corporations. I'll get my Wi-Fi turned on. And let me just show you what I've been working on. All right, so I'm building something called Eileen Bot. And for you guys who are parents, how much email and how much chat and how much spam do you have to deal with related to your kids? Anybody? How old are your kids? Anybody have older kids? High school kids, college kids. All right, so like how much of their mail do you have to process and go deal with? Email.
Coming to me about that.
Stuff that you have to deal with a lot. All right. So that's like a super common thing. And there's this whole parent tech stack. My kids are first grade and preschool. So I'm going to be dealing with this for the next 10, 12 years of my life. And this is just the set of apps that I have on my phone having to do with my kid. Some of them you recognize, some of them you don't. I just paid $4,000 into one of these because that's where I pay my tuition and stuff. But like, there's lots of these different little apps. And frankly, it's a problem, right? Like I have to deal with this. My wife has to deal with this. We have to figure out who's dealing with what. There are little announcements. There's SMSs, there's WhatsApp, emails, all over the place, all unstructured data. And you know, I want to be a good parent. I have FOMO for my kids. I don't want them to miss out. So I want to keep on top of all of this. So what I've been building is basically an AI assistant to help you with this. And that's what EileenBot's for. EileenBot's here to help you save time, keep you in the know. And what it really does is it distills everything down to 7 text messages a week that give me a summary of everything I need to deal with and follow up with. So a little bit of sanity in our lives. Me and my wife use it all the time. We've deployed it at our school. There's about 160 users, mostly at the school that I send my kids to using this now. So I like to model it as that friend who you ask questions to because they're in the know. The real Eileen, not this AI one, the real Eileen is a lady who's got a first grade kid, same class as my kid, and she's the person you ask questions to, right? She reads everything. She loves reading all the stories from the principals and all these other people. She reads all the field trip reports. She shares all the pictures from like she does all that stuff, right? I don't have the time for that. I have a job ostensibly. But that's what EileenBot's really trying to be. She's trying to be that other super parent but it's kind of in your pocket with an SMS interface. If you're a mom, you have to deal with things like mental load, all these things you have to keep track of. This kind of helps brain dump it so you can keep track of it with the app, right? And it maintains your privacy. I'm not asking for access to your inbox. I'm not asking for access to your calendar. You forward the information to the service and it kind of takes care of it for you. And then, I think one thing that's really important to me is I don't want another app. Again, I showed you that slide that had like 15 different apps on it. I want these things to be where I am already. I want them in my calendar and I want them in my SMS, and then I want to be able to follow up. And that's kind of the model. So instead of yet another app to go deal with, this is a purely SMS interface with a little bit of web stuff if you're doing configuration. This is me and my co-founder. This is really a pitch deck, but here's how it really works, right? So you text a question to EileenBot, and it comes back with an answer. Yeah, stop. So I don't know if the audio is going to work, but I'll just narrate as it goes. So I'm just using my phone, right? So the way I ask a question is I can go, hey Siri, ask EileenBot, when's spring break? Something like that, right? So when this video goes, what is this doing? Yeah, no, you don't need to download one. You can just use text messages. Why is this? It's super slow. Okay, so this is me basically asking the question using Siri, and it fills in the question. I'm asking about back to school night here. So it's actually sending the text message on my phone. Wait 10 seconds, and then the EileenBot with all the information kind of provides that information back. Again, this is an application. It's not like a tool like a lot of the folks at the Meetup are talking about, but it's a true application of LLMs and all these kinds of things. So yeah, this is all the information I need. Imagine you're driving and dropping your kid off to school or something like that, and you need some piece of information. Just talk to my phone, give me the information. 10 seconds later, I have it. Hooray! My life is easier.
So how do you get all this information in? That the rags, like they put some sort of a rag system approach?
Yeah, so behind the scenes, it's a RAG system. So the question is, how does the information get in there? And this is actually something that's pretty important. This is a class of students. So I just need one parent from the entire class to forward emails to the service. So for me, I have a kid in first grade and preschool, so I forward those to the service. And I've recruited some parents to forward things from kindergarten, second grade, third grade, fourth grade, so that they have their own grade-specific knowledge bases to do the Q&A. And yeah, the Q&A is RAG, multiple iterations to make it not suck.
Or you can just have the school send it, like make a deal with the school, and that's a service that like all those parents can get from the school.
And that is what I'm working with the director of communications, the preschool director, and the early childhood development. So I'm working on that. But for now, I've gotten 160 parents on this thing, and it's kind of grown organically, right? So I launched it at the beginning of the school year, September, and I monetized it. I have some paying customers now, which is kind of fun. Woo! $50 of MRR.
But there's a lot of like process, like filling out forms and all that. So you probably add an agentic layer and say, hey, I got some notice saying, oh, I have to sign up for volleyball, and then go just have your.
Well, so I'm just sending out those reminders, and like in the newer version, there's always a nudge. It's like, hey, click this link for more details. So there's opportunity here because this nudge is basically a place where the school could put an ad or a plea for funds or whatever. Or other people could kind of sponsor kinds of things. What's kind of the hook that brings people back is this capability. I'm basically looking at all these emails and looking for events, and I put them into a calendar, or I make a calendar that I can publish and that you can subscribe to, right? So this is all the events related to my kid's first grade class in the month of September, right? It's a lot. Some of them require my attention, some of them do not, some of them are optional. One of the things I'm working on now is adding a tagging system so that I can prioritize and personalize based on what you're interested in as a parent. Yeah, $5 a month.
I have one more question on urgency. So you said, I forgot the exact number, like 5 SMS per week or something. So let's say you are one day out, but then you receive this urgent email, whatever, teacher's sick, no English tomorrow. So how does your system deal with those, where it's off the regular schedule, but you need to know the soonest possible?
Yeah, so that's a great question. So at least the system at our school, I'll give you 3 concrete examples where something is urgent. Number 1, there was an active shooter incident at the college down the street from my school and that was in the news. So they sent out a text message directly to all the parents, not through the service. The school sent it. That's pretty important. I worry about my kid getting shot, right? Remember the tsunami warning? This was a month or 2 ago. They sent it out there like, hey, our school is 200 feet above sea level. You don't have to worry about a tsunami. And there was like this, related to that was the earthquake, right? Like, so those are the kinds of things that the school will tackle. And those are the things that are truly, truly urgent. Picture day is important. And if I get the reminder 1 day ahead of time, which is what we're doing now, you're going to remember to do it. Or the actual example for today is that deposit for next year's tuition is due tomorrow, right? So I saw that, and I took care of that before I came here. So most things are not urgent, and if they are, the school already kind of has that system built in. I don't know if I'm hogging all the time or not, but I don't know. Hopefully this is interesting. I am looking for other parents and other schools to try this out. I've been trying it at my school and working on a school, Hillsborough School District as well. But I am looking for more schools or sports teams or club activity type of things that this could work for. But the key thing is this. It's a community, right? So you just need one person that's going to be sending that information in. And then everyone else in that community gets the knowledge base, gets the ability to ask questions, and gets a shared calendar. Yeah.
I think we had one more person. Okay.
Thank you. I'm going to do a live demo, so if it breaks, please don't blame me. I'm a junior engineer. Oh, do you have a laptop that I can use, please? I just need cool. Do you have Chrome? Oh, can I use a ThinkPad with Chrome? Or this is Chrome by any chance?
This is Chrome.
Okay.
I think. Yeah, this is Chrome.
Okay. Let me ask a simple question. Who here likes to go to festivals? Say Coachella? Exactly. So who knows like the 5 main artists and then no one else? No? Is it just a me problem? So that's why I built Alka. So Alka is actually interesting because it's very related to what Vespa show. The main idea is that you upload a festival lineup, and then currently it uses OCR to detect all the artists on the flyer, and then it uses a Spotify API to match with to get your listening history, and then it gets you a personalized playlist for the festival. So say you are more, this is thought for like festivals like Coachella, where there is like multiple genres in that they're playing, but like say you are more into rock, less into pop, so give you more of the rock artists that you like and less than the pop artists. So this is the best way to like prepare for the festival. So this is currently in beta, or not even beta. I'm still getting Spotify's approval, so I don't have like a pitch deck or anything. Oh, should have not that done. Please don't do it. So since I don't, Since I don't have a flyer right now and I don't want to take up a lot of time, I'm just gonna demo like one of the past lineups that I have done it. The way this works is very simple. It just does OCR. Then I have a database with, I think, most artists on the planet. And then I use a simple LLM to discover which genre and then which artists are in the lineup. Then I have a scoring algorithm, and it will give you, the promise that it will give you at the very least 2 artists for everyone that's playing. So that's why you know, and it goes from like anywhere from like 2 to 6, depending on the size of playlist. And then it's very simple. Just go like playlist and the description. And then, how do you use this? Oh, sorry. And then if I go to Spotify, playlist should be right here. And that's it. It's not really more complex than that.
Well, this is looking great. Any questions?
Yeah, Spotify has like something that's like get your top tracks. So that will give you your like 2 tracks and top genres based on your listening history.
Do you have plans to eventually almost segment by stage, like if you're planning to hang out in one area of the festival the whole time?
That's actually a great idea.